So from here, as we can see, that there is no way we can say that this condition will be satisfied. Only for maybe some specific values this may specify, but generally this condition will not satisfy. So it means that this second condition will not be met. Okay, so second condition is not be met. So this means that this is not a subspace, okay, with this type of conditions. So for example, let's take a, b and c in some values. So for example, if take a1 is equal to say 2, and then we take b1 is equal to 2. Okay, so then c will be 2. Okay, so this is one set of values. C1 will be. If I take a1 is equal to 3, and then I take b1 is equal to 12, and maybe I take a2 is equal to 3, b2 is equal to 12, and I take c2 is equal to 6. Okay, in this case, so these conditions are satisfied by taking a times 2 times 2 is 4, which is 2 square. So 3 times 12 is 36, which is 6 square. So this, I have taken these values, something like these individual conditions are satisfied. But what will be u plus v? U plus v will be, in this case, will be a1 plus a2, which is 5, b1 plus b2, which is 14, and c1 plus c2, which is 8. Okay, so now 5 times 14 absolute value is equal to 8 square. So the answer is false. 5 times 14 is 70. 70 is not equal to 64. So this condition is not satisfied. So this, generally speaking, so it means that our result that if this is not a subspace is justified. Okay, so one more example. This is the fifth one. Just take like A, B, and C, and where C is greater than or equal to 0. So whether it is a subspace, so we can check it. The first condition, take A is equal to B is equal to C is equal to 0, because in this case C can be greater than or equal to 0, but that means we can take the value of C as 0. So first condition is satisfied, 0, 0, 0. That is no problem. Okay, so if we take now u plus v, okay, which is as we have done before, you take, if u is a1, b1, c1, v is a2, b2, c2, so u plus v will be a1 plus a2, b1 plus b2, c1 plus c2. Okay, so in this case, how can we check it? What we can do is, we can see over here is that a1 plus a2, b1 plus b2, c1 plus c2 are all of the same form. Okay, so, and if, for example, a1 plus a2, and then b1 plus b2, and then c1 plus c2, because in this case all the conditions are being met over here. So a1 plus a2 is the same as a1, real number. A is a real number, a1 plus a2 is also a real number. Similarly, b and b1 plus b2 are real numbers. C1 and C2 are also real numbers. And since individually each C is either equal to 0 or greater than 0, so which means that if C1 is greater than 0 or equal to 0, C2 is greater than or equal to 0, so then it will also imply that C1 plus C2 will be also greater than or equal to 0. So this third condition is also satisfied. So this means that adding conditions is also satisfied. So it means that this is closed under the addition rule. So second condition for the subspace is satisfied. First is satisfied, second condition is satisfied. How about the third condition? Third condition is R times U, so which is A1 plus A1 B1 C1 So it will be RA1 RB1 RC1. Okay, so RA1 and RB1 are same as A1, A and B, so real numbers. So we need to check about RC1. So RC1, so we know that C1 is greater than or equal to 0. Okay, if RC1 have to be greater than or equal to 0, then R should be greater than or equal to 0. Okay, if for example if RC1 have to be greater than or equal to 0, because we know that C1 is greater than or equal to 0, so then R should be also greater than or equal to 0. But here is the problem, because we say that R is any scalar. Okay, that means any real number. So it means that R can be a negative number. So R can be less than or less than 0. R can be less than 0. So for any value of R less than 0, this last term RC1 will be, so for R less than 0, RC1 will be less than 0. So this means that this condition will not be met. C1 is equal to 0. That means the last term can be a negative term. So it means that this with this condition, the third condition for the subspace is not satisfied. So this means that this is not closed under the scalar multiplication. So finally we can say that not a subspace. It is not closed under the multiplication, scalar multiplication. So it is not a subspace. Okay, next we can find another example, A, B, C. Okay, and the condition is that A minus 2B is equal to 0 and A plus 2C is equal to 0. Okay, this is the condition. So just like before, for the first condition, if we take A is equal to B is equal to C is equal to 0, so everything is 0, and we see that these two equations are also satisfied with 0 values. 0 minus 0 is 0, 0 plus 0 is 0. So first condition is satisfied. How about the second condition? The second condition is U plus V is equal to A1 plus B1, A2 plus B2, A3 plus B3. Okay, so it is the same as the first this vector. Okay, but we need to see that whether these conditions are met or not. So the meaning is that A minus 2B should be equal to 0. So that means, which means that this first element minus 2 times the second element should be equal to 0. So how we can say that? So A1 plus B1 is the first element minus 2 times the second element, A2 plus B2, and we need to evaluate it. So how we can evaluate it? So yes, so how we can evaluate it? This is A1 A1 plus B1 plus A2 plus B2 plus A3 plus B3. So A minus 2B should be equal to 0. So whether it is equal to 0 or not, so that we need to find out. So it should be A1 minus 2B. Okay. Okay, so to further clarify it, so for example, we can see also from here is that U was equal to A1, B1, C1. So from here, the condition will be A1 minus 2B1 is equal to 0 and A1 plus 2C1 equals to 0, just from this criteria. So okay, A1 minus 2B1 is equal to 0, A1 plus 2C1 will be equal to 0. And similarly, V is equal to A2, B2, C2. So it will be A2 minus 2, B2 equal to 0, and then A2 plus 2, C2 is equal to 0. So, but in this combined form, A1 plus A2, yes, I think I made a mistake over here. So that's why I was wondering something is not working very well. Okay, so here, yeah, actually I need to erase it, and it will be A1 plus A2. Okay, and then yeah, everything was wrong here. A1 plus A2, it will be a B1 plus B2, and it will be C1 plus C2. Okay, so now we apply this rule. So A1 plus A2 is the first element, okay, minus 2 times the second element, which is B1 plus B2. So now we need to evaluate it. So what is that? So A1 minus 2B1 and plus A2 minus 2B2. So we rearrange the terms. So what is A1 minus 2B1? This is equal to 0. A2 minus 2B2, this is equal to 0. So this means that this whole expression is 0. And for the second expression, so we need that the first element, A1 plus A2 is the first element, plus 2 times the third element, which is C1 plus C2. So likewise, A1 plus 2C1 plus A2 plus 2C2. So A1 plus 2C1 is equal to 0, A2 plus 2C2 is equal to 0. So 0 plus 0, so it is also equal to 0. So it means that this second condition for the addition rule is satisfied. So how about the third condition? So third condition is R times U. So it will be RA1, RA2, sorry, RA1, B1 and RC1. Okay, so from the first condition, RA1, that means minus 2 times B1. So what is that? So we take R as common, A1 minus 2B1. So since we know that A minus 2B1 is 0, so R times 0 is 0. So similarly for the third condition, from this equation, A plus 2C, so the first element, RA1 first element, plus 2 times the third element, which is RC1. So R common, A1 plus 2C1, and then R into this is 0, that is equal to 0. So third condition is also satisfied. So therefore what we can say that the given matrix with these conditions is a subspace.